Today's topic is volumes. After we previously discussed bind mounts, concept of volumes is pretty much the same. To memorize, bind mounts allows you to create a connection point between your local file system and a container, and you do it by creating a folder somewhere in your system with operation system specific commands, and then you use a mount flag for docker run command and specify a source, which is passed to the folder, and destination, which is passed inside a container where you want your folder to be bind to. So, and with volumes you use exactly the same syntax to mount a volume to a container. The difference is that you're not actually creating a folder by yourself. Docker does it for you, and it does it for you with commands like docker volume create, remove. Let me show you the whole list of commands. You provide a volume option, and here's a 5 commands, which is very similar to what we have in the system. Like make dir is similar to create, ls equal to our native ls commands in a terminal. We can remove our folder, and also there is an option to remove all the volumes that aren't used by any local container. So this command helps you to clean up your system a little bit. And why we need it? Well, by using these commands instead of our local file system commands, Docker abstracts away, it stores volumes, and the reason for that is very efficient and actually very smart. By doing so, Docker can implement volumes different ways. For instance, a local type of a local driver. Docker uses different drivers, and by default it uses a local driver that basically does exactly what we did with mounts. Docker will create a folder for any volume and will keep and keeps managing this folder if we provide different commands. But there are other drivers available, like SSHFS driver or S3, and if we configure Docker to use these drivers instead of a default local one, Docker will be able to store our volumes outside of your local machine. It will use S3, for example. This is AWS service. It will use S3 bucket to store your volumes, and this way you have a persistent storage point that isn't dependent on your local machine. And yeah, this is a very powerful feature, and this is why volumes volumes are common practice, and binds aren't so common to use. And one simple example, one simple use case with volumes and with this remote driver is as follows. You create an application that just do some operations, that does operations on a local folder, and this application doesn't know anything about Docker or volumes at all. It just uses a local file system it can access with default operations like creating files, reading files. When you complete your development, you create an image, and maybe you want to test your image. For that you create a local volume, and when it comes time to to publish your application to a production environment, you simply change a driver that Docker uses for for example, for S3 driver or SSHFS. SSHFS stands for a file system via SSH session, and this way your application in production isn't that different from what you have on your local when you locally test it, but it uses persistent data storage instead of temporary memory storage of the container. So this is very powerful approach of abstracting a volume, and we cannot do so with mounts, and this is why volumes are a major way to implement persistent storage. In terms of syntax, though, they're not that different from from bind mounts. Let me show you that. These 5 additional commands that you need to remember to actually create a volume. So let's create a volume. We do it with docker volume create command, and we provide a name option there, and we can somehow provide also a driver option here, but it's not in the scope of this video, and I definitely gonna show you how to use S3 volumes, but in the next video. For now, we'll stick with default option with local volume, and all the operations inside the container won't change much after we move to another driver, because inside the container we don't know how these volume points are implemented, and this is really a beautiful abstraction concept of Docker. Anyway, let's create a test volume, for instance. Test volume is created. We can inspect it with volume in ls. Here's our local driver. We can remove it with docker volume rm test volume. I'm using auto-completion by pressing tab button here, and inspect will show us some additional information about the volume, like where it located on the local system, and we can view it. It's an empty folder right now. And in case of remote volumes, we won't have a mount point located in a local system, but somewhere on the internet. Anyway, here's a name created at. This is some details of the volume, and volume, and another operation is prune. To just clean up all the volumes that aren't used. Anyway, now that we have volume created, an empty folder, let's attach it to a container. We do it with a similar command, docker run mount, and instead of specifying source as an absolute path, we just use our the name of our volume, test volume, and other options stays the same as in previous video. Destination, let's say our volume should be located at test volume folder, and as you remember, we provide in previous video we provided this type equals to bind option, and in case of volumes the value is different, but this is actually a default value, so we don't need to provide a type. And then comes other flags, like we want to run container in interactive mode, and also maybe we want to remove our container after we exit interactive mode, and here's our interpreter command. So this way we're able to run the container, our old app container that includes a Node.js HTTP server, but we're not now we're not for application here. We want to inspect our volume. So now it's actually an empty volume. Maybe we want to populate it with the content, with the file .txt, and this will update a global volume stored, not only a local for this container but also a global one. And to prove that, let's create another container. Let's actually exit this container and automatically remove it, so we don't have any running containers right now. And maybe we want to repeat our docker run command, and let's actually have two instances of the same image, and this is two different separate containers, and in both of these containers we can access our volume, test volume. And let's say that in all the things that's worked with bind mounts, like you can, if you update a volume from one container, it will also synchronize with others, with other containers using the same mount volume. Let's try it, creating a new file. Second, now in second container we have our file updated. So this is convenient. Another option is you can this is very useful sometimes when you don't know, for instance, you don't know what volumes are binded to a container. Well, first of all, you can find out it by running first, getting an idea of a container, and to show the list of all the volumes and actually bind mounts presented in this container. You provide you run docker inspect command, and with providing a name of your container or ID of your container, and you scroll up a little bit, and here is our list of mounts. Here's our test volume with the source and the destination, and also driver, etc. All the other options here as well. But maybe you don't know, or maybe you're just lazy enough to view this information, and at the same time you have a task to have all these mounts from a running container inside another container. So you do it like with a different command. Here's our previous command, and we need to change it a little bit. Instead of providing a mount itself, we provide a flag here, volumes from, and we need to specify the ID of a container here. So let's figure out what the ID is. Here's our ID, we provide it right here, and we save and execute this command. And this way, even though we haven't specified any mount options, we just specify what container we want to get volumes, all the volumes from. Here's our container, and now we're able to move here, and here's our volume. So what will happen if you have destination as destination already that already exists? Let's try it. Let's exit our current containers, and remember we now have a volume with two files in it. And what gonna happen if we change a volume destination to a directory where our source code for application lives? namely to app. It will copy the content of this folder to our test volume. Let's try it. For instance, we run this command, and now actually, if we have a volume already defined, and if it has some content, it will override information inside the container. So our app folder inside the container now doesn't have any source code. It only has whatever was previously created in the volume. And actually, to copy the contents of from the container to a volume, you need to have a clean and empty volume, and you can do it by either running docker volume create command one more time, or you can specify some unique name here, and Docker will create an empty volume if it doesn't exist already. So let's specify volume 2 here, and this way here's our application. And if we exit it right now, now we should have extra volume in our system, volume ls. Yeah, here's volume. And let me show you how you can view the content without running a container. You run the command docker volume ps volume 2, not a ps but inspect. You get this path here, and you can actually access it with sudo command. You need to be as a root user, and you inspecting it, and here is our source files. And now if we want to, and now we actually can transfer all the contents from this folder to any container. And this is useful when you want to create a backup. For example, you have a container, you create an amount, and you binding it to some folder inside the container, and after this operation you have a mount on a system that includes a backup of your of a folder. And now maybe you want to run a different container, like from Ubuntu image 16.04 that I have in my system already pulled. And now maybe let's change destination to from volume. And now after we connect to the container, we basically have our volume with backup, and we can do anything with it that we want. So I think that's it about for volumes for now. I will return to volumes to describe different drivers in a little bit more details. Yeah, and for now that's it.